A lot of our students have asked us, what is the intercept? Suppose imagine you have a plane like this, W transpose X plus B equals to 0, right? We often said that W here is the normal to the plane, is normal to the plane, right? And B is the intercept term. B is the intercept term, right? This is what we introduced. If you have a plane pi, right, where X is your dimensions. Here your X belongs to RD. If you have a d-dimensional plane, similarly W belongs to RD and B is a scalar. B is a scalar, right? This is what we described. A lot of students ask us, given this plane equation, which dimension does this intercept work in? Very valid question. So let's work from the basics. Let's go to our two-dimensional geometry, right? And also our three-dimensional geometry. So three-dimensional geometry might be slightly more interesting, right? So imagine if I have my three-dimensional space like this, right? My three-dimensional space like this. This is my x-axis, my y-axis, and my z-axis or z-axis, right? Suppose if I have a plane like this. So let me draw a plane. Imagine I have a plane like this, right? This is a plane, right? This whole thing is a plane, right? This plane is intersecting the x-axis, the y-axis, and the z-axis. So let me call this plane pi, right? Now, when I look at this x-axis, where does it intersect the x-axis? Let's say it intersects the x-axis at a 0, 0, right? It intersects the y-axis at 0, b 0. Let's assume it intersects the z-axis at 0, 0, c. Now, we can write the equation of this plane. This is very interesting. It's very easy to prove also. We can write the equation of this plane using just these three intercepts, right? It's intersecting x at a units away from origin. It's intersecting y at b units away from origin. It's intersecting z at c units away from origin. So given these three data points, we can compute the equation of the plane to be, like, this is called the intercept form of the equation of a plane. This is called the intercept form. This is called the intercept form of equation of a plane. You might have learned this in your 12th grade or in your undergrad first year when you learned coordinate geometry. The proof of this is very straightforward. You can just figure it out just using some simple vector operations, right? Now the equation of the plane can be written as x by a plus y by b plus z by c equals to 1. This is called the intercept form of the equation of a plane which intersects x-axis at a units away from origin, which intersects y-axis at b units and z-axis at c units, right? This is the standard intercept form, right? Now what is the equation of this plane? Suppose if I have to write the equation of the same plane in our general form. What is our general form? Our general form is our W transpose X plus B equals to 0. This is called the general form or the general equation of a plane, right? Let's write it. Let's expand it and write it. I can write it as W1X plus W2Y plus W3Z equals to, plus B equals to 0, right? Because what is this, right? This is nothing but your W transpose X. This is nothing but your W transpose X. This is your term B in the general form. I've just expanded upon this. Now, given the general form, let's try to see if somebody gives you the general form of or general equation of a plane, how do you convert it into the intercept form in three-dimensional space? First, let's see the three-dimensional space. Okay, then we'll generalize it to higher dimensional spaces, right? So now let's write these two formulae. W1x plus W2y plus W3z plus b equals to 0. Now we want to take this into the form x by a plus x by b plus x by c minus 1 equals to 0. Right? This is the intercept form. I'm just taking the 1 to the LHS. Right? Now to do that, what do I do? So I can rewrite this whole thing. First, if I multiply both sides by, because here, okay, let me rewrite this, right? It will be very quick. I can rewrite this as minus W1b x plus minus W2 by b y plus minus W3 by b z plus, minus, right? Minus 1 is equal to 0. What have I done here? I've just multiplied both sides by -1 and I've divided both sides by b. That's all I have done. Now here, if you look at this equation, this is where the fun begins, right? So now if you look at this, this is same as this 1 by a that you have here, right? So if somebody gives you the equation of the plane in this form, you can convert this into this form. Now if you look at this, you have -1 here, you have -1 here. You have 0 on the RHS, you have 0 on the RHS. So now your minus W1 by B, right? Or if you invert this, so let's invert this. So 1 by minus W1 by B, which will become B by W1, right? So this is equal to your x-intercept. Because what have I done here? I've gone from the general form, I've converted the general form of the equation of a plane to the intercept form. And in intercept form, I know that the denominator here is the intercept on x-axis. Sorry, here I should write y and here I should write z. Sorry. This is the intercept on the y-axis, this is the intercept on the z-axis. I know this. So, given the general form, my intercept on the x-axis is minus b by w1. My intercept on the y-axis is minus b by w2. My intercept on the z-axis is minus b by w3. So given the general form of the equation, right, we can always compute the x-intercept, y-intercept and z-intercept using, see here, b is called the intercept term. It is not the exact intercept itself. This is called the intercept term, to be precise, because this intercept term is what is useful, right? This intercept term is what is useful in computing the exact intercepts that you have for x-axis, y-axis and z-axis, right? I often use the word z and z interchangeably, okay, just a habit, that's it, right? So given the general form, you can easily compute the intercepts on x-axis, y-axis and z-axis using this simple formulation. Now, if you all recall, in 2D, which we learned probably in our high school, right, we learned this formula y equals to mx plus c as the intercept form in 2D, right? Here we said c is the intercept on y-axis, right? Now let's dissect this. Why is it so? Using this formula of something in the intercept term, right? How do I convert this? So let's rewrite this formula, right? I can write this as y minus mx minus c equals to 0. I just brought these two terms to the LHS. Now I can write this as y by c plus minus m by cx minus 1 equals to 0. Right? Now when you have this, what is your x-intercept here? Your x-intercept will be minus c by m. And what is your y-intercept? Your y-intercept here is nothing but c. Right? Because c is what you have in the denominator of y. Right? And we are inverting this to get the x-intercept. Right? So in a nutshell, this formula that you have is a simplified version in 2D of what you should have in 3D. Right? So given this major takeaway, given any plane in any dimensional space, so let's say my equation of the plane is w transpose x plus b equals to 0, and let's assume x belongs to d-dimensional space and my w also belongs to d-dimensional space. For any of the ith dimension, if I want the ith dimension intercept, if I want to find the intercept on the ith dimension, it will be equal to minus b by my weight corresponding to the ith dimension, or the vector, the ith component of the vector w. This is again derived from just this simple thing. This is what we have, right? For x-axis, y-axis and z-axis. Whatever we are learning in 3D, now we are just scaling it to higher dimensional space, right? So given any plane in any dimensional space, right, you can compute its ith dimension intercept by just using minus b by wi. Now this b here is called the intercept term because it is used in computing the intercepts. That's very, very important to remember. Again, there is one more catch here, which is, here we say c is the intercept on the y-axis, but we never talk about the intercept on the x-axis. Actually, imagine if you have a plane if you have a line like this, right? This is x, this is y, right? We often say that this is equal to c, Let's assume this is my equation of the line or the plane. But this line or plane also intersects the x-axis at somewhere. It intersects the y-axis at c units away from origin. But it also intersects, let's not forget that it also intersects x-axis. This value is nothing but minus c by m, which you've derived here, right? So when a plane, this is very important, in any dimensional space, in 3D, 4D, ND, if your plane does not pass through origin, right, it will intersect all the other dimensions, not just one dimension. It will intersect all the other dimensions, and you can use this simple formula to compute where it intersects or where it intercepts the ith dimension using this simple formula. I hope this confusion about the intercept form, which some of our students have asked, is clarified now.